Sometimes we need the number of permutations possible using all the objects from a set, but only a few at a time. Take note on page 676, talks about the number of permutations. So the number of permutations of n items of a set arranged r items at a time is our n value, our number of items, how many we need at a time, p for permutation, which means a particular order, and our formula is n factorial over n minus r factorial. So 10 students are in a race. First, second, and third place winners will win medals. In how many ways can 10 runners finish first, second, and third with no ties allowed? So here, our total number of students here is 10. Order matters, so we're going to use permutation. And the amount we need at a time is going to be 3. First, second, and third. So we have 10p3. It's going to be 10 factorial over 10 minus 3 factorial. Factorial over 7 factorial. Okay, we can simplify this if we wanted to. 10 times 9 times 8 times 7 factorial over 7 factorial. 9 times 8 is 72 times 10 is 720. Okay. We also could have typed in 10 factorial divided by 7 factorial using our PRB key. Divided by 7 factorial, which gets me to 720. We can also type in this. So if you press 10, your PRB key, and it should already highlight NPR, click on that, then press 3, it gives you 720 as well. So if we do 10, PRB key, enter, 3, enter, it gives us 720 as well. So a few different ways we can do those. Now, in how many ways can 15 runners finish first, second, and third? So our number of runners here is going to be 15. That's our total number. It matters the order. It's not just which ones are top 3. It's which one is first, then second, then third. So order matters. So we're looking at a permutation, and we need 3 people that we're picking. That's our R value. So 15. P3. Again, it's 15 factorial over n minus r factorial. 15 factorial over 12 factorial. We can simplify that for those of you that don't have calculators. 15 times 14 times 13 times 12 factorial divided by 12 factorial, which means 15 times 14 times 13 is 2,730. That should be the same thing we get if we type in 15 factorial divided by 12 factorial, which I got 2,730. And also if we do 15, our probability for our NPR, and then 3. I also got 1,730. So a couple ways to very quickly and easily check your answer there. 2,730 ways that 15 runners can finish first, second, and third. Now, suppose that the first 3 runners advance to the championship race. In that case, the order doesn't matter. A selection in which order does not matter is a combination. Okay, we're taking the top 3 placers. It doesn't matter where you finished. There's no rhyme or reason to it. We're going to randomly draw straws to see which lane you get or where you start in relationship to the starting line. Doesn't matter. We're just taking the top 3 in each. So combinations on page 676. The number of combinations of n items of a set chosen r items at a time, So our number of items total, the number that we're choosing, and a combination where our order does not matter. We're going to take n factorial divided by r factorial times n minus r factorial. So the difference here is this. Example 4, finding NCR here. What is 13C4, which is the number of combinations of 13 items taken 4 at a time. So our n value, our r value. 13 factorial over 4 factorial times 13 minus 4 factorial. 13 factorial over 4 factorial times 9 factorial. 13 times 12 times 11 times 10 times 9 factorial. Okay, that'll let me simplify my 9 factorial here. I'm also going to write out my 4 factorial. 4 times 3 times 2 times 1. Because 4 times 3 is 12, and 2 goes into 10 5 times. So all I really have here is 13 times 11 times 5. $715. Okay. We can also do the same thing again by typing in this, as long as we remember to put parentheses here. We can also do 13 PRB over 1, enter, 4, enter in our calculator, and type it in as this. So 13 PRB over 1 to the NCR key, enter, type in 4, enter, and I got 715 as well. So a few different ways to check your answer there again. Now, what's the value of each expression? I'm going to have 8 factorial over 3 factorial times 8 minus 3 factorial. Eight factorial over 3 factorial times 5 factorial. 8 times 7 times 6 times 5 factorial. We'll cancel my 5 factorials. And 3 factorial is 3 times 2 times 1. 3 times 2 is going to cancel with my 6. So all I'm going to have left is 56. Okay, also we could have done 8 factorial divided by, in parentheses, 3 factorial times 5 factorial. Gets me to 56. Or I could do 8 PRB over to NCR 3, enter, and I get 56. So lots of different ways that we can do these. Okay. 9 factorial over 2 factorial times 9 minus 2 factorial. Again, we can simplify our factorials. 2 factorials, 2 times 1, which gives me just a 4 here. So I have 9 times 4 left, which is just 36. So a lot of times these can be simplified fairly easily without a calculator. So if you don't have it or can't find it on yours, that's fine. Again, we could have typed in 9 PRB NCR 2 and gotten 36 as well. 15 factorial over 5 factorial, 15 minus 5 factorial, n factorial over r factorial times n minus r factorial. 15 times 14 times 13 times 12 times 11 times 10 factorial, because 15 minus 5 is 10 factorial. I'm going to go ahead and cancel those out. I'm also going to rewrite 5 as 5 times 4 times 3 times 2 times 1. And I'm going to simplify what I can here. 3 and 5 make 15. 4 goes into 12 3 times, and 2 goes into 14 7 times. So what I have left is 7 times 13 times 3 times 11, which gives me 3003. I also again can do 15 PRB over to NCR 5, 3003. Identifying whether order is important. For each situation, determine whether you should use a permutation or combination. What's the answer to each question? A chemistry teacher divides his class into 8 groups. Each group submits one drawing of the molecular structure of water. He will select 4 of the drawings to display. In how many different ways can he select the drawings? Okay, here it doesn't matter what order they use. It's not like there's a first place, second place. He's just going to randomly pick 4, randomly throw them up on the wall. So this is going to be a combination. There are 8 total, and we're using 4 at a time. So 8C4, which is 8 factorial over 4 factorial, 8 minus 4 factorial, which is going to give us 70 possible ways. You will draw winners from a total of 25 tickets in a raffle. The first ticket wins 100, second ticket wins 50, third ticket wins 10. How many different ways can you draw the 3 winning tickets? This order does matter. It's a permutation. The first one gets more, okay? Second one, 50, third, 10. The order is important. There's a particular order, so we use permutation. There's a total of 25. We said it's a permutation. And R means 3. We're drawing 3 winning tickets. So 25P3. Again, we can either use our factorial notation, 25 factorial over 25 minus 3 factorial, or we can type it in our calculator using our formula. 25 PRB, enter, 3, enter. There's 13,800 options. Now, in example 5a, which was the chemistry teacher problem, how many ways are possible for the teacher to select and arrange the 4 drawings from left to right? So here, order matters. She's putting them up left to right. So we're going to use permutations. We have 8 groups. R, we're using 4 at a time. So 8P4. 8 NPR key 4 gives me 1680. Again, we could have used our formula for permutations, which would have been 8 factorial over 8 minus 4 factorial, and gotten to the same place. Big idea recap here. Multiplication can be used to count the number of ways that certain things can happen. And here is your assignment.